Okay, so we are live here. I'm going to cover another aspect of Swift here, which is deinitialization. And I'm going to first share my screen really quick. Let's go ahead and do this. And we will, let's see, let's do share my screen. Yeah, so first we'll start with this, and I'm going to cover today. Let's get into here. I'm going to go to the language guide, which should be under documentation, Swift language guide. There we go. So I'm going to cover deinitialization. Last week I covered initialization, and I'm going to talk about how a class instance is deallocated and what the deinit keyword is able to do. And I'm going to talk about how Swift automatically deallocates your instances when they're no longer needed to free up resources. And this is through the Swift memory management system, which is called Arc. So I've actually used Arc before for a commercial product when it first came out. And it was actually very helpful because I guess I'm lazy. I don't want to manage memory. I want a tool to do it for me. It's kind of like AutoML, the same thing. I would prefer for a tool to solve the problems for me. So here's what we're going to cover. I'm going to dive into opening up another playground. Let's go ahead and do that next. So I'm going to do this. I'm going to open up another playground, and I'll share that next. All right. And let's go to this. There we go. And I'm going to say file new playground. Here we go. Blank. All right. Got this thing working. And I will share a different screen. Here we go. The screen. And here we go. Okay, so deinitialization, not necessarily first on the mind probably of many people, but still an important topic. What does it look like? It looks like this. When you're going to deinitialize something, you would type in deinit, and they're called though automatically before an instance deallocation occurs. So that is helpful to know about. But let's take an example that they're going to give us here. So if I go through here and I say, okay, here's a bank class. Inside we have a static variable, coins in bank, and then we have a static function, distribute coins, number of coins, let number of coins to vend. And in particular here, the static function will basically increment here. So if I go through here and I initialize this, the bank will keep track of the current number of coins it holds, and it will handle the distribution and collection of coins. And then in order to receive the coins, we could make another one. So we could go down here and we could do, we'll say receive coins. This in here. There we go. And then each player instance is initialized with a starting allowance of a specific number of coins during initialization. And the player class defines a win method, which retrieves a certain number of coins for the bank and adds them to the player's purse. So then the player class also implements a deinitializer, which calls a player instance. So basically the idea here would be that this, I believe, is going to wipe out things at the very end. And so if we go through and we call this, we've got both the bank and we've got the player. And then we can actually start running this code. So first step here, we would create an instance of the player one, which is an instance of this player class. And then we would say a new player has joined the game. And then we would go through here and print this out. So here we go. New players join the game with 100 coins. And now if we say there are how many coins left, we would go through here and say there are 9,900 coins left in the bank. So basically, every player is requesting 100 coins if they're available, and this player instance is stored in the player variable called player one, which is optional. And this variable is used because the players can leave the game at any point, and this will optionally let you track whether there's a current player in the game. Because the player one is optional, it's qualified with an exclamation point, and when the coins in the purse property is accessed to print its default number of coins, it will use the win coins method. So let's go ahead and take another piece of code here and do a little bit more work. And so basically we've got this, here we go. And so this is showing that the player now only has, the bank only has 7,900 coins left because player one has won 200 coins and now has 2,100 coins left. And then if we go through here and we say, here's the player that has 2,000 coins, the player's purse contains 2,100 coins and the bank has 7,100 left. So we can go ahead and print this. And if we go through here, we can see that in fact that is able to work. And so now that the player has left the game, this is indicated by setting the optional player one to nil, which means no player instance. At that point, the player one's reference to the player instance is broken. So no other properties or variables are still referring to the instance. So it's deallocated in order to free up memory. And before this happens, the deinitializer is automatically called. So this is a pretty good example here of how when you need to deallocate things manually, in the case of building some kind of game, you can do that by, again, calling this deinit method here to reduce basically everything that was in an instance of the actual player. So it is pretty cool to be able to go to that low level and control things. And I think this is a pretty good example of why you would want to manually deinitialize things and not just let the automatic reference counting take place. All right, well, that's it for today. I will cover next week optional chaining, which is for querying and calling properties, methods, and subscripts on an optional that may currently be a nil. Okay, see you next week.